Okay, so this is going to be an extension of the factoring technique for quadratics that we looked at before. And so now we have a special case which is called the difference of two squares. Okay, that's how that's usually referred to. And the reason it's called that is because we're going to look at something like x squared minus 4. Okay, so a special polynomial where we have the difference, subtraction, between two numbers that are perfect squares, x squared and 4. So the x squared is a perfect square of x, and 4 is a perfect square of 2. So this is the idea that we have here. And it turns out that the factoring for this is really pretty simple. You can get that right from the expression, and all you do is this. We're going to have the sum and the difference of the square roots of our two terms. In other words, take a look at the two factors or the two terms that are making up your difference of two squares and take their square roots. If we square root x squared, we get x. If we square root 4, we get 2. And then write the sum and the difference of those. So let's just do a couple easy examples here just to be sure that you got the pattern. X squared minus 9 is x minus 3 times x plus 3. Now notice this is difference of two squares, so if I have x squared plus 9, I cannot use this method, okay? Cannot use it with a plus, has to be with a minus. X squared minus 64, x minus 8, x plus 8, and so on. Now we can extend this one level of complexity where we look at this term here, and we can actually put a number in here and still work with this. And let me show you an example of what I mean here. Let's say we have 16x squared minus 4. Okay, we see that we have two numbers subtracted here, and we could write this as something minus 2 and something plus 2. That takes care of our 4 here. Well, what about this over here? What's going to happen with this is pretty much the same thing we had before. Let's take a look at our x. X squared gives us x. And if we square root this whole term right here, the x squared gives us x and the 16 gives us 4. So 4x is really the square root of 16x squared. So if you think about it like this, 4x squared is 4x times 4x. Okay, that's 4 times 4 times x times x. I just multiply everything together. And this gives me x squared, and this part here gives me 16. So this factorization comes out like this. So even with a number in front of my x squared out here, I can go ahead and use this same pattern. Let's just do a couple more. 25x squared minus 100. Okay, 25x squared, square root of that's going to be 5x. Square root of 100 is 10. Let's do 49x squared minus 36. Okay, what do we have here? 7x minus 6, 7x plus 6. So difference of two squares, really pretty easy once you know what the pattern is to get the factorization. I'm going to throw in one more thing that you might run across somewhere. Let's go ahead and clear this screen here. And it's pretty much just like what we just got done doing with the 25x squared minus 100 sort of a thing. What if I had 16x to the 4th minus 64x squared? How could I deal with that? Well, it's really the same idea once again, because look at this term here. If I take the square root, I'm going to do the same thing I did before, but now the square root of x to the 4th is x squared, because x squared squared is x to the fourth. Remember, when you multiply numbers with exponents with the same base, you add the exponents. Okay, so this part, x fourth, gives me x squared, and the 16 still gives me, for square root, 4. Over here, this looks like the first term that I had in this kind of expression, and so we know that that part right there is going to be 8x, and so the factorization here is 4x squared minus 8x, 4x squared plus 8x for that one. One last thing, you may have noticed I started off this video with a plus sign here and a minus sign here. Obviously it doesn't make any difference which order we multiply these in. Whether I put the plus or the minus here, as long as I've got the opposite one on the other factor, then I'm good.